Hello all. So as we have discussed about the introduction of sound and human effect on sound in the next previous session. So today we are going to discuss few terminologies related to the sound intensity. So I have opened the link for the same, and the link is there in the description box of the video as well. So as you know that sound intensity is also called as acoustic intensity, which is defined as a power carried by the sound waves per unit area in the direction perpendicular to that area. So highlight this thing that the area, whenever you are calculating or solving any numerical related to that, so that area should be perpendicular to the area of power applied or power carried by the sound waves. Okay. And as far as the SI unit of the intensity, you know that that is also equals to watt, which is watt per square meter. Okay. And one application of noise measurement of sound intensity in the air at listener's location as sound energy quantity. Okay. And sound intensity is not same physical quantity as the sound pressure. As you can see in the unit suggest that unit of this same is watt per meter square, which is just similar to your sound pressure. So in the physical consideration it is not similar, but human hearing is sensitive to the sound pressure, which is somewhat related to the sound intensity. Okay. So let's go to the mathematical formulation of the same things. So as you know that sound intensity is denoted by I, which is equals to the sound pressure multiplied by particle velocity, which is I is equals to P into V. But as you know that these two sound pressure and particle velocity are vector quantities. Okay, which means that both have some directions as well as magnitude. So the direction of the sound intensity is the average in which energy is flowing. So we have to calculate the average sound intensity now. So for the calculation of average sound intensity, you have to integrate it from 0 to t, which is the limit of time. Okay. And these two, sound pressure and particle velocity, are the function of time. So integrate this from 0 to t with a function of pt and vt at a rate of dt. Okay, then you will get this formula, which is equals to I is equals to 2 pi square v square delta square pc, where rho is your frequency of the sound, this is rho, and delta is the amplitude of sound wave particle displacement, and rho is the density of medium. Okay, rho is the density of medium, and c is the sound speed of sound. Okay, so if you will quote all these value in this formula, then you will get the value of sound intensity here. Now there is a very prominent term in the study of sound, which is called as inverse square law. Okay, so what do you understand by this inverse square law is that intensity of sound or sound intensity decreases at a rate of 1 by r square from the center of sphere. Okay, so this is r, which you will see or whenever you are calculating the surface area of any sphere, so this r is the radius of that particular sphere. Okay, so this intensity is inversely proportional to that particular r, which is radius. Okay, so as you can see here that for a spherical sound wave, the intensity in the radial direction as a function of density r from the center of a sphere is given by IR, which is equals to P divided by area in terms of R, which is equals to 4 pi R square. So now the intensity formula will be related with the sound wave pressure, which is P divided by 4 pi R square, where P is sound power, AR is surface area of that sphere with a radius of r. So in this way we can say that intensity is inversely proportional to 1 by r square or 1 by radius square. So that's why this relationship is called as inverse square law, which is maybe in your RTU curriculum in the university exam they may ask you during MCQs or maybe 1 marks or 2 marks question. They will ask this inverse square law, how you can define or what are the relationship between sound intensity and radius of sphere. Okay, now the last thing is sound intensity level. So sound intensity level or SI, this is in the short form it is called as SIL, and acoustic intensity level. It is a level of intensity of sound related to the reference value. Okay, if you are taking any reference value so related to that, you can calculate the sound intensity level. It is depicted by Li and expressed in bells or decibels. Okay, which is the unit of this particular term. So as you can see, Li is equals to 1 by 2 ln I upon I naught. I naught is your reference sound intensity and I is the sound intensity for which you are calculating the sound intensity level. And this is NPA. 1 NPA is equals to 1 is Napier, 1 by 1 B is equals to 1 by 2 ln 10 is Bell, and 1 decibel is equals to 1 by 20 ln 10, which is called as decibel. Okay, so common used reference sound intensity for the air is 1 watt per meter square. Okay, so for this is the common reference value for the air which we used to take. So now the equality of SIL and SPL requires I by I naught is equals to P by P naught square. Okay, P is your the particular parameter for your object for which you are calculating, and P naught is the reference value, okay, or reference sound pressure. So in this way you can calculate all the sound intensity level. Okay, so in the next term we will video we will try to see that what are the basic vibration characteristics, and we will go with the curriculum of Rajasthan Technical University syllabus of mechanical vibration, which is there in the third year 6th semester mechanical engineering curriculum. So thank you so much for your patience listening. Thank you.